This time I have a Sansui receiver in that's going to make any Sansui fan smile. It's a Sansui 9090 receiver. This one here is in very good cosmetic condition, and it has a problem. It has intermittent severe distortion on the right channel. So this one, we're going to have to pull this one apart and see what's causing it. Let's check it out. This is a Sansui 9090. Complaint on this one is that the right channel goes distorted. So we're just running it now. I've heard it at the customer's location. The right channel was extremely distorted. But right now it's working. Oh, there we go. Hear the right channel? The channel's clear. So we have a distortion on the right channel. That's what we're going to investigate. See what's causing it on this unit. If you remember my 9090 that I have, this bracket's missing for this card, and as is the covers that cover the transistors at the back. Missing on mine. This one here is complete. First thing to determine is whether the noise is coming from the preamp or whether power amp. So the way to do that, of course, is to isolate and run the preamp through my external amplifier and see whether we're still getting distortion going through an external amp. So I'm going to unplug the main outs to the power in. We'll connect it to my test amplifier. Putting it in mono. Enough channel. Preamp is sounding clear, so let's check the power amp. The problem is clearly on the power amplifier because it sounded okay when I was clipped in. Actually, I can. It's coming back. You can see it fades in and out. If I just get a bridge the right channel output into my other amplifier and see if it's clear coming through that. Okay, I've got the amplifier running now. I'm just bridging that preamp out into the left speaker of my other amplifier so I can turn my other amp up. And we hear it clear as a bell. This is the same channel we're listening to. The right channel. See how distorted it is here? That's the preamp out. So we got a problem probably on the driver board here. See how bad that's getting? It comes and goes. Now it's going to come back. So we have to investigate the driver board on this one. I'll show you guys how I wired this up so you can see what I'm talking about. So I just clipped on, as you can see, to the main out jumper and clipped that onto my input to my amplifier. Had the ground just plugged into another common grounded bus or common ground terminal, so my amplifier had a ground. So we were listening to the preamp output that's going into the main amp, going through my test amp as well as going through this one. And going through my test amp, it was clear. Going through the amplifier inside here, it was distorted. So we have a problem, more than likely, on this board here. More than likely. It's coming and going. It could be capacitors going bad. Let's pull the board and check it. So we remove a couple of screws in the back here to remove the clamp, and then I can remove the board. We'll be checking some of these caps here, and we'll check some of the ones on this board here. The way it's distorting like that, it almost appears like a transistor may be going bad. Some of these ones here were known to go bad, or a bad connection, but we'll give the board a good once over. The symptom also sounds like it's losing a voltage, and it's going into severe distortion. So it could be a transistor that's causing this, or a bad connection, or a cap, or even a fuse that started to internally start to go open intermittently, where it connects and then it disconnects and you lose one of the voltages. Let's just do some ESR testing on a few of these caps in the driver. There's only like 3 of them. So we have a couple 100 microfarad caps. This one's a 6.3 at 100. I'm just testing the right channel, which is this side of the board. And this one here is measuring 0.31. 100 microfarad at 6.3. Well, a 10 volt would be 1.2. So as you can see, this is well below that. This other one's a 100 microfarad as well, and it's coming up at 0.06. So those two are okay, and if I compare them to the other channel as well, make sure that this one's dead. Again, 0.08. So it's not capacitors that have gone bad. Everybody blames capacitors for everything that goes wrong. They say, you know, everyone blames caps. This one's 6.5, as is, what is this other one on the other channel here? 7.1. What value of these ones here? They're 0.47 at 50 volts. So, I mean, they don't even register, so they're going to be fine as well. So it's not a capacitor, at least not on this board. We'll check some of the caps here on the main board. These are filters going into here. This is the right channel here, and this is the left channel. And that's confirmed by testing the inputs back to the preamp inputs over here at the back. The right channel comes up on this pin, and the left channel on this one, which is feeding in to these 2 capacitors. These are the input caps going into the board. Right channel input, left channel input. And they go through these 2 caps first, and then everything's on the board. So what we'll do now is I'm going to put the board back in. We're going to hook up the scope, and we're going to monitor at various points on the board here to see where we get the distortion. Because we know it's good coming in because I bridged another amplifier right to the input, and it's good here. So the problem is somewhere between here and the output, and I don't think it's going to be a bad output. They normally don't fail. I'm not saying they can't fail like that, but they normally don't. I think it's going to be one of these driver transistors here has gone bad. One of these amplifier transistors, or one of the drivers, or it could be a bad connection. So I'm just kind of looking to see if I see any connections here that look like they may be cracked. And maybe I'll go over those with a magnifying glass and just take a close look and see if we've got any cracked connections. Because the way it's behaving, where it cuts in and out, it's either going to be a transistor that's got a junction going bad, or a connection itself, just the way that it's acting up. That's right on one of the transistors right there. Even this one here. Look at this one. Look at that connection here. You know, that connection doesn't look good, does it? I'm going to redo a couple of these ones because that connection there almost looks like it was ready to crack. I can see it moving. I'm going to redo a few of these and we'll try it again. See Let's get me heat up my soldering iron. See, as good as these units were back in the day, if I wiggle the transistor, you can even see that connection there looks like it could be broken. And that goes onto this tracer. I'm just going to put a blob of solder over here. I'll do all of them here, but I'm going to just go over this board first and just see if I resolder the board and resolder everything, it looks bad, and if it stops cutting out, then we know that we've got the problem. But just visual inspection, that's the number one thing when you're looking at this vintage stuff. Don't automatically assume that capacitors are bad, because usually they're not. And anyone that tries to tell you different is an amateur. And I know I've said this before and I'll say it again. There's a lot of so-called professionals out there that charge a lot of money. Like, they'll go through an amplifier like this, and some of these guys will have no problem charging someone $600 or $700 to recap an amp, and that's 9 times out of 10 is not the problem. Because these type of caps generally don't go bad. There's no switching power supplies in here. Most of them are rated at a much higher voltage than what they were operating at. Like, even the main filters on this one, they're Elna, they're rated at 71 volts. They're not running these anywhere close to 71 volts. They might be running them at 60, maybe 65. But they're not running them over the rated voltage. It's one thing if the seal has failed and the electrolytic is spilling out. Yes, they're shot. But as we saw when I measured these ones with the ESR meter, you know, the 4 caps or 6 caps I measured on here, they're all good. None of them are bad. They're not in an area of the circuit that's going to also get a lot of heat. Maybe this one here because it's closer to the heat sink, but then again, heat rises, right? It's not sitting in the path of the heat. Heat that's produced on this heat sink is going to go up because this is down on the board, right? So typically not a big problem on these type of designs. I have a cat in here, as you can probably hear. The solder mask on these boards is very, very thin, so it comes off without much effort.
copper isn't very thick either. It'll come off with without much effort too if you put too much heat on it. And boards of this era were not very good. This was early on in circuit board development, and they just hadn't perfected it quite yet. So we have a lot of connection problems on these older circuit boards. It doesn't take much for it to crack right around the controls here, especially. Make sure that they're soldered down well. I'm only concentrating on the right channel. I think this is the right channel. Yeah, this is the right channel, of course, because the left channel was fine. So I'm just basically going over all these connections that a couple of them look like they could use a touch-up. So I'm just going to go over them all because there's not that many. Tell you, the cat will disappear pretty quick if a splash of solder drops on it. The cat's right below my feet. Oh, can't have any bridges. Can't have any bridges. That would make things go boom pretty quick. Of course, this would have been made back in the day before there was automation, so these boards would have all been put together by an assembly line of young women in Japan, because it was typically women that did this work. No man would stand for this repetitive work, right? They'd send it off to the women to do it, because that's the way it was. If you look at any of the old videos out there circulating around from old films showing TV manufacturing and so forth, the guys would do things like make picture tubes and build the wooden cabinets and stuff for the console TVs, but all the chassis work was all done by women. They had the patience to do this tedious soldering work, put one component on and solder it in and then send it on to the next station. Worked with a guy that used to always joke when a customer came in about why something breaks down, right? People would always grumble and complain when their electronics broke down and it cost them money to fix it. And one of the guys on the floor, he would say, well, it's because it was made by man. If it was made by women, it would never break down. Little did he realize that all the stuff that was manufactured in the time frame of what was breaking down was 99% chance that most of the assembly was done by women in the factories, because that's just the way it was. Now, of course, you go to look at the iPhone factories and stuff, it's all done by children. Or a lot of it is. Child labor is a problem in some countries. This is the one that's making all the noise, wanting some attention, right? This cat's got a bent tail. I joke with people and say it's because it got its tail caught in the screen door, but it actually wasn't. It was actually born that way. It's got a bent tail.
its mother had a bent tail too. Genetic problem. And a cat falls down. So power the unit up. So this is through the amplifier. We'll just monitor this and see whether I fix the problem. It's clear now. So I got to monitor it for a while and see whether the distortion comes back. If the distortion does not come back, then the problem was connections on this driver board. Let's monitor it for a bit and see what happens. Of course, what I'm thinking, it could be a transistor, right? Could be a transistor, but what I'm thinking is as the transistor heated up and heat transferred into the connection let go. Change the bias, transistor cut off, transistor cooled down. Could be the transistor itself, could be a connection. So that's where we're going to run it. If I can run this thing and have it run for a couple of hours, because it would act up within a few minutes. If I can run this thing for an hour and it not do it, then it's pretty safe to say it was a connection. If it still acts up, then it's going to be one of these transistors. It's bad for sure. So we're just going to monitor it. I got the scope connected, so if the distortion comes back, I'll see it. Got the scope going here. As you can see, the waveform's clean. So it's going to monitor it for a bit. Fingers crossed, problem solved. Now the reason I'm scoping this transistor is, of course, this is the one that the connection was found that was bad on the bottom of it. Sounding good. It's clean. As clean as one of these amps can be, right? They weren't the cleanest in the world, but they had a lot of power and they had a nice sound. That's why I'm hanging on to the one that I have. Although the time to sell one would have been last year, because they were going for upwards of, you know, $2,300, $2,400. There's one right now that's listed for sale for $1,100. That shows you how depressed the market is now in vintage. I don't know the guy that paid for this, because he just bought it. He bought it, didn't realize it was broken, and then found out when he got it home that it had a problem. And the guy that he bought it from just said, "Too bad, all sales final." So I've got it to resolve. But this one here, the guy that owns this just bought this. I don't know what he paid for it, but I'm sure he probably paid a fair bit. But they're a nice receiver. They really are a nice receiver, and that's one of the reasons I'm hanging on to mine. Well, it's been going now for probably 20 minutes. Haven't heard any distortion. Can't seem to get my camera to focus on the scope. Come on, camera, you can do it. There we go. Yeah, it's looking good. That's the right channel. If I switch over to the left, you'll see nothing on the scope. We're monitoring the right channel. Everything's sounding good so far, so kind of looks like I found the problem, just connections on this. I'm going to continue to monitor for a bit. So if you got one of these big brutes that's got distortion, first clean all your switches and controls, because they are known trouble areas on these units here. Remember the driver board. Connections where it plugs in and solder connections. These boards were not very good as far as their construction goes. They're basically a laminated paper board like everything was back in the day, and they developed connection problems. The fact that it's vertical, any movement and shifting and so forth, even when it's clamped in place, you've got components that can, because not every component is mounted, can move and cause solder connections to crack. I mean, after all, you got to remember, these things go back to the late 70s. So these are very old units today, but still going strong. So we're still testing it as I'm slowly putting it back together. I've got the covers in place now. Still got the scope monitoring it. It's now been going for probably about an hour. Now, some of you might ask, did I proactively redo all the connections on the other side of the board? And the answer to that is no, I did not. I looked at them. I did not see any that looked to be visually poor. And the reason I didn't go over, I guess I could pull the board and go over them just preemptively. We could take the board out and do that. But I didn't, because I didn't see any that were visually problematic. This one here on this transistor, when I moved it, it literally moved. So obviously it was bad. And one of the reasons for not going over the circuit board, I mean, there's pros and cons. Whenever you put heat on it, you could inadvertently cause the trace to start to lift, which could cause future problems. So that's what the cons are. The pros are, if there are any connections that are ready to fail, you can prevent them from failing by going over it, but at the same time, by going over it, you could generate future problems just from the heat transfer into the foil, because these old boards, the foil, the glue, the adhesive that held the foil down, 55 years ago, or whenever these were made, 50 years ago anyway, let's say 50 years ago, the glue that was used to hold the copper down wasn't great, and putting heat on it can cause the adhesive to start to lift. So by just going over every connection, that could create future problems. And that's why I generally don't do it, because even though some might suggest that it would be good preventative maintenance, I'm more worried about what damage could be caused from heating the board with these old circuit boards like this. And that's another reason why, besides the fact that when you start just changing out caps for the sake of changing them out, you are putting stress on the board. No matter, even if you take them out with a desoldering pump, you're still heating the traces, and heating the traces can cause the bond between the foil and the board to break, and now you've got the weight of the component, and all that's holding it in place is the actual foil itself, and the foil, as you've seen, is quite fragile. So that's the second reason I don't just go in and start changing out caps. And the big one, though, was a customer I had about 10 years ago, and unfortunately I didn't do a video on this because it was before I was doing videos, but I had a guy bring me a high-end amplifier that he had done his research and was convinced that it needed a full cap job. The amplifier worked. There was nothing wrong with it. He just was convinced that because he read something on the internet about doing caps, that he wanted it done. I'm trying to remember what it was. Might have been a Pioneer. It was either a Pioneer or Kenwood. But anyway, it was a big integrated amplifier that he had. And there was nothing wrong with it. It worked fine. But he was convinced that all the caps needed to be changed. And the reason he was convinced of that is because, of course, he read stuff on the internet. Of course, we know how the forums are on the internet, right? Every expert out there has a different opinion. You know what they say about opinions, right? They're like assholes. Everybody has one. But the internet experts said that all the capacitors had to be changed if it was over 20 years old. Just something you had to do. So of course he bought a cap kit for a couple $100 off of eBay, which contained all the main filters and all the coupling caps and everything in the amplifier. And he brought it to me, and I changed all the caps out for him. All the caps in the tone control, all the caps on the driver, power supply. And he paid me for it, and I listened to it. It sounded fine. I didn't hear anything wrong with it. To my ears, it sounded fine. And he gets it home, and he's not happy. He's on the phone. He goes, "What the hell did you do to my amplifier? It sounds like crap." I said, we'll call him Steve. That's not his name, but we'll call him Steve. I said, "Steve, what are you talking about? It sounds great." "Nope, sounds like crap." He brings it back. I put it up on my bench. I'm listening to it. "What's it? I don't hear a problem. It's not sounding right." "What do you mean?" "It just doesn't sound right. That's not how it sounds." Well, I put all the parts in. Showed he had the bag of parts because I handed him when I changed all the parts. This is a guy that if he doesn't see the parts in his hand, he doesn't believe that they're changed. So I put all the parts in a bag and I handed him the bag and said, "Well, you know, this is how many parts. You got your parts list. Look all your parts listed," because it came with like step-by-step instructions for a do-it-yourselfer. I said, "Look at all the parts. Count all the capacitors. Count all the ones in the bag. These are the ones that came out of your amplifier." Didn't matter. He wasn't happy. He said he wanted me to put the original ones back. So I took them out and I put all the original ones back in. He paid me again, by the way, to do it because that's the way it is. And he was happy. So then well, how come they sell these parts kit if they don't make an improvement? And I laughed and I said, "Because there's a sucker born every minute." He had no comeback to that one. That was One full cap replacement job I did, it was a nightmare because the guy was kind of an ass about it. And I've never done a full cap job on any amp since. I go through with the ESR meter, I test the ones that I suspect are bad, and I change the ones that are either have low capacity or bad ESR. And it's never failed me. And back when I worked in the shop, for the 20 years I worked in the shop, we never did a full cap job, not once. If someone came in and asked for it, they'd be told to take it somewhere else, just because we didn't have the time, right? The owner of the shop wouldn't waste hours doing it. He would tell people it wasn't necessary. And I tell people the same today. It's not necessary. When you're talking circuits such as this, these capacitors are not running at anywhere near their limit, and most of them are either just filter capacitors or signal coupling capacitors. They're not being pushed to the limit. Where caps are being pushed to the limit is in the newer products, which use switching power supplies, which are operating at high ripple current, which tends to dry out the electrolytic. Another problem with the newer caps, and this goes back to 10 years ago with this fellow that I did all the caps for Steve, was that a lot of these old capacitors that were made 50 years ago, the chemical cocktail that's in them that makes up the electrolytic is using hazardous chemicals, which they can't use anymore. Some of them will contain PCB oil, others will just contain mineral oil, but they still have hazardous chemicals, which they're not allowed to use anymore, because when the unit gets recycled, either it's put into a landfill or it's burned in an incinerator. Either way, if the components contain hazardous chemicals, they're going to be released into the atmosphere if it's incinerated, or leach into the groundwater if it's buried. Not every country has disassembly, down to component level. A lot of them will take, like a lot of places like here, when we send something off for recycling, they break it down, they take the circuit boards out, they take out the copper, like they take out the transformer and the metal, they separate the metal, the glass, and the wood, and the circuit boards go into a smelter, where they're burned up under high temperature to recover the metals, to recover the copper and anything else that's in them. But any components that are on the boards, they get smelted. So if you've got hazardous chemicals in capacitors, they're going to get burned up. So the trend started around, I think it was probably in the 90s, late 80s into the 90s, maybe late 80s. They started, I think it was even earlier, it might have been mid 80s, because that's when the capacitor problems all started, was mid to late 80s and into the 90s. They started changing the chemical composition of capacitors. Now you can have two identical capacitors with identical rating, an old one and a new one. Pass an audio signal through it and listen to what comes out the other end of the capacitor. You'll hear a difference, or you can hear a difference. I'm not saying you will, but some people will definitely hear a difference. And it's just because of the chemistry that's inside. It has different electrical characteristics at different frequencies. So that's another reason to not just recap for the hell of recapping, because it's not necessarily going to solve any issues. Now, I've been talking to you here while this is playing, because we're still testing. As you can hear, clear as a bell. And the waveform is good. If we look on the scope, nice clean waveform. And a camera that can't focus. I don't know what it is about this. It must be the refresh rate of the scope that's causing the camera to hunk. But my other camera does the same thing. I have to put it in manual focus, or it just doesn't seem to want to focus on the CRT screen. it's sounding good, so I'm gonna say this one's good. So I'm just gonna throw it together now, and I'll let it run, continue to run for a while, but nothing's getting warm, everything's cool. I say I gotta do on mine. I gotta rebias mine, because mine at this level, I would feel heat coming off the outputs just idling. My own, I've got the bias is set quite high, so the transistors are in a little heavier conduction. That tends to clean up the sound a bit, by the way, but mine hasn't been checked in a long time, so it's probably time to pull mine out of service. Not that it gets used that much, it's just used on my vinyl setup, but it might be time to pull mine out of service again and just go through it and set it up, because it hasn't been done in years. I set it up when I repaired it, and that was back in the 1980s. The only thing I've done to mine since then is clean up the switches and the controls that went dirty, but the actual preamp or the driver board and the outputs, it hasn't been touched since I overhauled it when I got it back in the mid-80s, when I had to change all the outputs on it, all 8 of them, and a bunch of drivers and resistors and stuff that were burnt up on it, because that's how I got it. It was blown up when I got it. Anyway, thanks for watching. We'll catch you in the next one. Bye.